Okay, so I pushed the wrong button on the recording, so bless you. So I'm going to talk about number 1 real quick again for those of you watching at home. When you're multiplying fractions, we're just going to go straight across. So we have 3 times 4 is 12. 7 times 7 is 49. This will not simplify. There are a couple of ways we can check that. I can look back at the problem. 3 and 7 won't simplify. 4 and 7 won't simplify. When I look diagonally, 3 and 7 still will not simplify. 4 and 7 still will not simplify. If I did all of my simplifying here, my answer should be completely simplified in the end. We also just mentioned that you can type in the fraction 3 over 7 times 4 over 7. Remember, my calculator recognizes that backwards L is that fraction button that we use. When I hit enter, it gives me 12 over 49, which was the answer I got when I multiplied across on the top for 12 and across on the bottom for 49. Yes?
Another way to check your answer is that there's like, if you hit the second button and there's like I think it's like next to a 0, it says answer. It's like a different color text. You can just put that and then hit the enter sign and see if it's because it says answer. The answer is for 1249.
Right, so what you would actually use that button for, you would actually use that button for something completely different. So like, let's say, what's the opposite of multiplying? Dividing. So technically, if I divided 12/49 by one of these, shouldn't I get the opposite one? So how you would actually use that would be to hit second and then my answer down there, which pulls up answer. Now when it says that, that's the most recent answer we got, which was 12 over 49. And then I can just hit divided by. Which one do y'all want to divide by? 3/7. So I'm going to hit 3/7. What should I expect to get? 4/7 just by checking that. And when I hit enter, I get that. Okay? So what that answer button really allows you to do is not have to retype in your fraction. Okay? All right. On the next one, I have 3/8 divided by 6/9. Now again, we don't want to just depend on our calculator. We want to know how to do this on our own. What is our rule for dividing fractions? Addison? Keep, change, flip. So I have 3 over 8. Change it to multiplication. And then I flip that fraction. Guys, what is that called when I'm flipping the fraction? Reciprocal. So really it's like keep, change, reciprocal. You're finding the reciprocal every time you flip it. Okay? So from here, now that that's multiplication, what could I do? Gabby? Let's simplify. Instead of multiplying and getting big numbers, let's go ahead and simplify. What 2 numbers would you like to simplify? 3 and 6. Okay, those are easy. 3 will go into 3 how many times? Once. And 3 will go into 6? 2 times. Remember, you have to be dividing by the same number. In this case, I divided both of them by 3. So now on the top, I get 1 times 9, which is 9. And on the bottom, I get 6 times 2, which is 16. So I get 9 over 16 as my answer choice. Are we okay with that? All right, again, I do have the calculator, so just to double check my answer, I'm going to hit 3, fraction button 8, divided by 6, fraction button 9. Make sure we're using that fraction button appropriately. And I hit enter, and I do get 9 over 16. All right, number 3. Yes?
Oh, couldn't you just put like 9 and 16 and then press equal?
Yeah, you could. If you just wanted to see if it simplifies, you could just type in 9, fraction button 16. Just to check and make sure you simplified your answer, that's absolutely fine. If you type in the whole problem, that also allows us not just to check simplifying, but to check our dividing operation. So, multiple checking methods. All right, so for number 3, right now I have 2 mixed numbers, 6 and 2/3 times 3 and 3/4. Can I multiply that as it is? No. What would I have to do if I was going to multiply this out? What would I need to do? Ben?
6 times 3 and then plus 2.
6 times 3 plus 2, forming that Urkel circle, as y'all like to call it. All right, so 6 times 3 is? 18 plus 2 is? 20. So I'm going to write it up here because I have a little bit more room. So I end up with 20 over 3. Remember that denominator doesn't change. Times? Same thing over here. Urkel circle again. 3 times 4? 12 plus the 3? 15 over 4. Now again, before I multiply, what could I do here? Before I start multiplying that out, what could I do? Sean? Simplify. So what two numbers do you want to simplify, Mark?
20 and 4.
20 and 4. 4 will go into both of those. So 4 divided by 4 is 1. And 20 divided by 4 is 5. All right. Anything else that we want to simplify here? Julia?
3 and 15.
3 and 15. 3 will go into both of those. 3 divided by 3 is?
1.
And 15 divided by 3?
5.
So now on the top, we get 5 times 5?
25.
And 1 times 1? 1. What is 25 over 1 the same as? Ben?
25.
25. All right. Now, I'm not going to lie. Yesterday, I saw some funny stuff on this 25 because we were all like calculator happy. All right. So let's type this into the calculator because the calculator, y'all got so goofy. So let's just check. Remember, guys, when I'm looking at this mixed number, 6 and 2/3, is 6 still important? Is 6 still a part of that fraction? Yeah, it's not necessarily in the numerator or in the denominator, but it is a part of that mixed number, which makes it a part of that entire fraction as a whole. So we're going to hit 6, and then I'm going to hit my fraction button because that 6 is a part of it. And then I'm going to hit my 2, which is my numerator, my fraction button again to separate the numerator from the denominator, and then I'll hit the 3. Times 3, fraction button, 3, fraction button, 4. All right. When I hit equals, we get 25. Now, here's the thing. What is next to that 25? A decimal. If I was going to write that as my answer, would I ever say 25 dot? 25 point? 25 decimal? 25 and there's nothing there? No. So do I need to put a dot next to my 25? Do I need to put the decimal next to my 25? Absolutely not, okay? Plus, also remember, like my rule, my super picky crazy math rule is if you got fractions in the problem, there should be no decimals in our answer. We're going to work with the fraction. We're not changing or putting decimals in there. All right, remember our decimal and fraction worlds need to be separate or they'll take over the universe and destroy math. Okay? Keeping our fractions and decimals separate for now, all right? Okay, so our next one. We have 5 1/4 divided by 4 1/2. All right, so this one's going to be a little bit longer because we got to change my 5 1/4 to a improper fraction. So 5 times 4 is plus the 1. So I'm going to kind of like go way up. Let me move my paper down some so we can see what we're doing. So I get 21 over 4. That's still division right now, isn't it? Okay, 4 times 2 plus the 1. So I get 9 over 2. Now that I have two improper fractions, can I keep change flip? Yes. So now we're going to keep 21 over 4. Change it to multiplication. We get 2 over 9. And then from here, if we wanted to simplify, 4 and 2. 2 will go into both of those, yes? 2 will go into 4. Twice. 2 will go into 2. What number can go into 21 and 9? 3. 3 will go into 21. 7 times, being careful that it doesn't fall into my other problem that I just did. And 3 will go into 9? 3 times. So now when I look at this, I have 7 times 1, which is 7, and 2 times 3, which is 6. So I got 7 over 6, which is improper. We know we're going to have to change that around. All right. 6 will go into 7. 1 time with how many left over?
1/6.
So I should get 1 and 1/6. So let's type that into our calculator. Make sure we can type that in correctly to check our work tomorrow. Not tomorrow, Friday. So I have 5, fraction bar 1, fraction bar 4. Divided by 4, fraction bar 1, fraction bar 2. Okay, so typing that in carefully. I got 1 and 1/6. Can y'all see where the 1 and 1/6 is on my calculator? All right, so what makes this look funky? What makes it look funky, Noah? Yeah, it has this weird like letter U in between here. Guys, that U is the calculator's way of putting a space between there. Also, the calculator would interpret this as one whole unit with 1/6 1/6 left over. Okay, so the U actually does stand for something. It's one whole unit. Okay, one whole number with 1/6 next to it, which is what we put as our answer, isn't it? Okay, I'm going to rewrite it next to that just so I know, hey, there's where the answer is. Okay, because it got kind of way off to the side. All right, guys, as you can see, I'm running out of room, so let's use our graphing calculator, our scientific calculator, just to go ahead and type these in and get our answers. So we have 8 times 3, fraction button, 2, fraction button, is that a 6?
Yes.
Okay.
Yes.
All right, and what do we get as our answer here? How am I going to write that out, Brittany?
26 and 2/3.
26 and 2/3, thank you. All right, has someone already typed in the next one? What do we get for that next one? Tucker, what'd you get? 11/15. That's the correct answer. All right, please, if you did not get that, double check your work, double check what you typed into the calculator. Are there any questions before we move on to the next part? All right, we're going to speed it up from here a little bit. That was a lot of review. We hadn't looked at those in a while, so I wanted to take a lot of time there. Number 7 is just asking for the reciprocal. Guys, if it is only wanting the reciprocal, you're not simplifying that reciprocal. You're not making it a mixed number once you get the reciprocal. You are only worried about flipping. Okay, so what do we get for number 7, Brittany? 8 7s. We just flip that around, so it becomes 8 over 7. All right, what do I get for the next one? 10 12. Ben? 12 over 10. Next one, what do we get? Jessica?
1 and 7/6.
1 and 7/6 is super, super tempting because you just take that fraction and flip it. Now, here's the dilemma with that. That 1 is kind of a piece of this fraction. So we can't just flip one part of it. What do I need to do before I flip, Nathan? We need to do the Urkel circle thing where we do change it to improper. So 7 times 1 is? 7 plus the 6. So I actually have 13 over 7. Now can I flip it?
Yes.
Yes. Do not flip until you have just those two numbers. So my answer here is actually 7/13. All right, Mark?
And the last one is 2/3.
The last one is 2/3 because when I do Urkel circle, 1 times 2 is 2 plus 1, 3. So that's where that 3 came from in our answer once we flipped it. All right, number 8. What is the numerator when 1/3 is divided by 2/3? Well, first thing we have to do before we can find the numerator is actually divide. So we're going to do 1/3 divided by 2/3. Which means we keep, change, flip. All right, guys, again, we're going to go through this a little bit more quickly. So I'm just going to do 1/3 divided by 2/3. What do I get as my answer there? 1/2. Okay, so I'm going to put equals 1/2. Now, here's a question. Did it ask me what is 1/3 divided by 2/3? No, it said what is the numerator? So raise your hand. Which part of that is the numerator? Tucker? 1. All right, number 9, there were a couple of different ways to do this. All right, the first way, we can actually use this picture of the house that's given to us, okay? So it says Bill used 10 bricks to make the house that is pictured. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Y'all see the 10 bricks? That's his bricks, okay. Exactly 1/5 of the house will be painted brown. That means 1 out of 5 bricks are going to be brown. How many bricks are on that top row? 5. How many of them are we going to paint brown? 1 of them. How many bricks are on the next row? 5. How many am I going to paint brown? 1, because it says 1 out of 5. So now when I look at that entire house, how many bricks are painted? 2 bricks. All right. Guys, just for the sake of being able to get through all of this, your test tomorrow is multiple choice, right? Okay, normally, how would you have to write this answer? In a full, complete, detailed sentence. Guys, for right now, I'm just going to pick the main part. Our main answer here is 2 bricks. If we wanted a full sentence, we could say the total number of bricks that will be painted brown is 2 bricks. All right, for right now, guys, we're just going to put in that short answer Friday. It will be multiple choice. All right, but please don't lose those skills where we've been practicing all year. All right, what's another way I could work this out? Jacob?
5 is half of 10, so...
Okay, so already we're kind of taking off on a different different path than what I had pictured. Because where does it say anything in here about a half?
Nowhere.
Okay, so I don't want us using a half. I don't want us taking that road. I know where you're going. You can get to the right answer, but it has some kind of flawed logic for right now, okay? I'm talking about just the skills that we've been learning recently. Andrew?
You could do 10 times 1/5.
We could do 10 times. Do you see right here where it says 1/5 of the house? What is the house made up of? This is 10 bricks, right? So that's 1/5 of, what does of mean? Multiplication, 10 bricks. Do y'all see that? So that's really 1/5 of times 10 bricks. What is 1/5 times 10?
2.
2. We get the same answer. We get the exact same answer, okay? All right. Let's look at number 10. On 10 different days, Bill, typo there, sorry guys, Bill read a book for 1/5 of an hour. What is the total amount of time Bill read this book? So whenever I read a word problem, I'm thinking, am I putting stuff together and combining it? That would be addition. Am I taking something away or leaving something off? That would be subtraction. Is something repeating? Is something happening over and over again? That would be multiplication. Or am I splitting something up? Am I dividing something out? That would be division. Which operation is going to apply best here? Tucker? Multiplication. Because Bill's reading this 1/5 of an hour, how often? For 10 different days. He's repeating that action. Do y'all agree? So those 10 days, I'm going to repeat the action of reading for 1/5 of an hour. Okay, so when I repeat 1/5 for 10 days, what do I get? 2. Look back. Didn't we just do 1/5 times 10?
Yes.
Yep, there it is. We just did that. So now down here, we're doing the same math, really. All right, so 1/5 times 10 times 1/5 is 2. 2 what? Bella? Hours. Very good. 2 hours. All right, because again, what is it that was repeating? Were my 10 days repeating? No. 10 is the number of times it repeats. The 1/5 of an hour is what repeated. So 2 hours would be the option. All right, guys, I've seen a lot of people today that have written minutes. Did it say anything in this problem about minutes? No, don't change your hours to minutes. That's just causing extra math where you could make a careless error. Brittany? Yes, sentence. Go for it.
The total time that Bill read for 10 days is 2 hours.
The total time that Bill read for the 10 days is 2 hours. Very good. All right. Let's go to number 11. Yes.
For number 10, whenever you did that, I did my multiplication differently. Because what I did was an hour 60 minutes. So I did 60 times 1/5, and that equaled 12. And then
Okay, so that 12 is talking about minutes, right?
right, and then but whenever I saw the 10, I added a 0 because I knew that would be right. And then I put 2 hours.
I don't want us changing it to minutes because that step right there, that's a step where we could make a simple mistake. All right, if it's given to us as 1/5, so this should have been shorter than all the steps you took, isn't it? All right, you got the right answer. That's awesome. We kept track of all that work. That's awesome. Let's keep it short and sweet using that information and. Yeah, I lost my train of thought. I just paused. Okay, let's go on to number 11. Okay, so again, guys, don't change it into minutes. It's going to cause you extra steps that could cause a careless error. All right, Owen, question?
It wouldn't be wrong though, right?
If you put 120 minutes, this is a multiple choice test. That's probably not going to be an option because minutes wasn't mentioned in this problem. Okay,
It says what's the total amount of time, not like how many hours.
That's true. It does say what its total amount of time. Again, I'm telling you this is a multiple choice test tomorrow. On Friday. If it's a multiple choice test and it's talking about days and hours, I do not imagine that the answer choice would be in minutes. Okay? If on a test, if you gave me 120 minutes, technically that's the same thing. All right? I wouldn't count off. But again, why cause ourselves that extra step when I can just do 10 times 1/5? Okay? All right. Number 11. When making a pizza, John uses 1 cup of sauce for every 2 cups of cheese. Complete the ratio table and find out how many cups of sauce are used when John uses 10 cups of cheese. We want to graph the ordered pairs. When we were completing the ratio table, a lot of people just wanted to skip down and fill in that empty box, which is completely possible. What am I doing to 2 to get 10? Timesing it by 5. So what would I do to the 1? Times it by 5. 1 times 5 is 5. All right, that's absolutely fine. But then have I completed the ratio table? No, I still have 6 boxes here that haven't been filled in. So let's fill those in. That leaves room for 1, 2, 3, and 4. All right. If 1 cup of sauce has 2 cups of cheese, 2 cups of sauce has 4 cups of cheese. 3 cups of sauce, 6 cups of cheese, and 4 cups of sauce,
8 cups of cheese.
8 cups of cheese. All right, very good. All right, we're wanting to find out how many cups are used when John uses 10 cups of cheese. So there's my cheese. That's the answer that we're looking for. We're not going to write out that sentence just quite yet because we have a couple of other things to do. All right, it says graph the ordered pairs. Have I listed my ordered pairs anywhere yet? No. So let's go ahead and list out those ordered pairs. What's my first ordered pair going to be? Sean. 1, 2. All right, and then after 1, 2, what are we going to have? No?
2, 4.
2, 4. All right, and then Mark?
It will be 3, 6.
So it would be 3, 6. And then Annalise? 4, 8. And then Amelia?
5, 10.
5, 10. Okay? Ordered pairs, check. All right, we need to graph the ordered pairs. Before I start graphing them, what do I need? Gabby? Labels. We need labels. I've got to label what the X is talking about and what the Y is talking about. In some of my classes, they were like, oh, you have to have a title. The title is helpful. The title gives it a complete finish. But the most important thing to go on here is my what on earth is X talking about? What on earth is Y talking about? So what is my X talking about? Noah. X is talking about sauce. Now let's think about this for a second. If I just write sauce here, would 1 sauce, 4 sauce, 10 sauce. Does that make sense, Addison? No, what do I need? Cups of sauce. If you just put sauce, just please add that in there. Cups of sauce. All right, so then my Y is going to be talking about cups of cheese. Cups of cheese. Okay. All right, now we're able to graph this. So we have 1, 2, so that's 1 cup of sauce, 2 cups of cheese. We're going to find where they meet and put a dot. 2 cups of sauce. 4 cups of cheese, find where they meet and put a dot. 3, 6, 4, 8, 5, and 10. Okay. All right, so everything looks good. The only thing I would say is, remember, I don't want you to just circle the 5 in the chart. What would I want to do for my answer, Brittany? Yeah, let's just write that out. All right, so we're going to put 5 cups of sauce. All right, and again, like I'm not writing a complete sentence right now to conserve time, but I do want to write out my answer clearly. 5 cups of sauce is needed. Maybe I am going to write a complete sentence. For 3 cups of cheese. 10. I did that a minute ago, last period too. I don't know where I'm getting 3 from. So 5 cups of sauce is needed for 10 cups of cheese. Make sure you write the correct information in your sentence. Yes, Andrew?
Technically, you do need the arrow, and you also need something else. You need the person needs to know the graph is increasing at a constant rate, because if they're trying to find 10, would it jump randomly?
All right, so this didn't actually ask us to describe the pattern, so we don't have to write out that it is increasing at a constant rate. All right, and it's not asking us to find a future point, so you don't have to put your arrow. If you did put your arrow lining that up, that would be fine. But your arrow is usually used if we're trying to find a future dot on the graph. Annalise?
If you didn't put the
Write it in. write it in, and yes, we would need to count off because we need to make sure we state our answer to the question. A lot of people, we did all of this. Got to make sure we state the answer to the question that was asked. All right, number 12. Number 12 is a little tricky for some of us. All right, so I want you to pay attention very closely as I look at this top line. What's happening for 3 to 5? I went up by 2, so I added 2, correct? Then I'm going from 5 to 7, which means I'm going up by. Then 7 to 9, going up by 2. Guys, am I going from 9 to 11? Am I going up by 2 this time? No, I'm only going halfway there. I'm only going halfway there. I'm only adding 1. Do y'all agree with that? The key thing is I'm not going all the way to 11. I'm only going halfway. Okay, so now down at the bottom, what am I doing to get from 4.5 to 7? I'm adding 3, and then to get from 7.5 to 10.5, I'm adding 3, and then to get from 10.5 to 13.5, adding 3. Now again, remember this is where we went plus 2, plus 2, plus 2. Then we only went halfway there. We only went plus 1. So what do you think I'm going to need to do on the bottom here?
Plus 2.
Add 1.5.
Amelia?
Add 1.5.
Add 1.5 because that is half of 3. I'm only going halfway to the answer, so I'm only adding half of that number, which gives me 15. So I get 15 cups of tomatoes. Did that get any of us? Did that one trick any of us?
Yeah.
A couple of us. All right, so just be careful. What was that?
I found the unit rate. I put 4.5 on top, and then put 3 on the bottom, and then found the unit rate, and then I added the unit.
Okay, so I like that. So what Andrew is saying is he put 4.5 on the top and he put 3 on the bottom. What did that give us as our unit rate?
I put 1.5 tomatoes, and then 1 serving.
So that gives us 1.5 over 1. So now if I want, instead of 3, I want that to be a 10, right? So we can just multiply that by 10. So that's using unit rate. So we also get 15 over 10, which is what we had over here. All right, so very, very clever. I like that. All right.
You can take the 1 also and just put it on the top, because it's 9 plus 9 is to 10 plus 1. Because that you have to do the top.
Yes. Yes. All right. So let's flip over onto the back. All right, number 25. It's a word problem, so first thing I'm going to do is start kind of analyzing my operation options. Am I combining? Am I taking stuff away? Is it repeating? Am I splitting it up? If the family's going on a bike trip and we want to bike 72.5 miles from our house, but we're only traveling 18 and 1/8 miles each day, how many days will it take us? Again, what operation are we going to be doing here, Sean? Division. We're taking those 72.5 miles and we're splitting it up to where we only do 18 and 1/8 each day. When I divide that, what do I get for my answer here? Alex?
4 days.
4 days. Thank you. All right, what about on the next one? Jasmine has 5 and 5/6 dozen cookies. If 2 and 1/3 dozen cookies fit in each box, how many boxes can she fill? What operation are we doing here, Brittany? Division. I'm going to take that 5 and 5/6, and I'm going to split it up. I'm dividing it into 2 and 1/3 for each box. What do I get when I divide that? What do I get when I divide that? Sean? 2.5. All right. So there's been a couple of arguments here. All right, some people have said, well, 2.5 isn't a complete box, and it said how many boxes can she fill? So, guys, at that point, I will take it would depend on your sentence. Again, if we were writing these out in a sentence, it would depend on how you worded your sentence as to if 2.5 was appropriate or if you would want to put 2, because this is completely filled. Completely full. All right, so 2 are completely full. 2.5 would just be how many will fit. Yes?
If you put 2 and 4, what about number 25 if we put 4?
Number 25, the only option is 4 days. Because when I divide that, I get the whole number 4. All right, that's a really good question. So if I divide that, so make sure if you type it in wrong, it's going to give you the wrong answer. So make sure you do 17 1/2. Sorry, 72. Sorry, 72. I typed it right. I just said it wrong. Thank y'all for keeping me on track. Divided by 18 and 1/8. All right, do you see I got 4 exactly? So I wouldn't take any sort of decimal or fraction on that one. Okay? All right, let's talk about number 27. Number 27. Now, the way that I work this on my own is actually different, but then one of my classes today was like, but I did it this way, and I was like, oh, I like that way more. So I love it when y'all apply what we've been doing in a different way than I originally did it. So we're talking about Kevin here. Kevin makes 7 out of every 10 free throws. Jolene makes 9 out of every 12 free throws. Who is better at making free throws? So let's talk about Kevin first. All right, and what was brought up today was they actually changed them into percents. Because if I have the percentage of free throws that Kevin made and the percentage that Jolene made, isn't that a direct comparison? All right, so I really like that idea. How would I write Kevin's initial ratio that's given to me? No? 7/10, so 7 over 10. Now, right now, that's not a percentage, so what would I do first to change it to a percentage? Gabby? Divide. Let's make it a decimal. All right, so we're going to do 7 divided by 10, which gives me 0.7. Now, to make that a percentage, what do we have to do? Sean? Move it to the right 2 times, which gives me 70%. So Kevin has made 70% of his free throw shots. All right? So now let's look at Jolene. Jolene, what's Jolene's ratio? 9/12. Very good. So we're going to divide that. 9 divided by 12 gives me 0.75. Y'all got those calculators. Make sure you're working this with us if you haven't done it this way. All right, so now we can move that over 2 places. So what percentage did Jolene make? 75%. So you see how that gives us a very clear comparison. All right. Now there was another option for how we could have worked this. Another way we could have done this. I'm going to kind of go over here. All right, and talk about Kevin and Jolene one more time. So I got Kevin had 7 over 10. Jolene had 9 over 12. All right. Another way we could have done this is just found a common denominator. What would be a good denominator for 10 and 12? Julia? 60. So we can multiply these by 6. So that gives me 42 over 60. These we can multiply by 5. So that gives me 45 over 60. Who still did better? Jolene. Either way, Jolene here got 45 compared to just 42 for Kevin. Over here, Jolene got 75% compared to just 70% for Kevin. So either way, Jolene was better at making free throws. Brittany?
So I got Jolene for my answer, but if I did the method of the better deal, is it wrong?
If you did the method of the better deal, that's fine. So you used unit rate, correct? Unit rate is absolutely fine. So that's like where we compare our better deal. So get 1 on the bottom for both of them, which would be, so you would be comparing your 0.7 and 0.75, right? So make sure you make that a 0.70 so you don't think it's just like 7. Okay? All right, so I'm going to put Jolene because she makes a higher percentage of her shots. All right, when I was doing it over here with those equivalent ratios, with the common denominator, for my answer on that one, I had put Jolene because the equivalent ratio measuring 60 throws shows Jolene completed more. All right, so for those of us at home, if you want to pause it, this is the answer that we put for the other option, Jolene, because the equivalent ratio measuring 60 throws shows Jolene completed more, and that's where I've done that math again if you want to pause it to take a look at that. Okay. For number 28, we're talking about 3 equivalent ratios for 3/4. What is an equivalent ratio? Quickly, Ben.
6/8.
6/8. So the way that you got 6/8 is you multiplied 3 times 2 and got 6, 4 times 2 and got 8. What's another equivalent ratio, Tucker? 9/12. So we multiplied them both by 3. Give me a more interesting equivalent ratio, a more interesting one. Ashton?
36/48.
36 over 48. What did you multiply yours by, Ashton? 12. So we did 12 times 3 is 36. 12 times 4 is 48. All right, I had another class where they multiplied theirs both by 87. They got some really big numbers. You got a calculator. It was interesting. I thought, well, that's kind of cool. Another class, they multiplied by 100. All right, 300 over 400. That one's easy to do quickly. Andrew?
I was just going to say you could just keep on adding 1 0 after everything.
Yeah, so we could do like 30 over 40, 300 over 400, 3,000 over 4,000. Those would all be equivalent as well. All right. Yes, Jessica.
For one, if you do 3/4 times 4,000, you get exactly 3/4.
Right, because you're just multiplying the top. Remember, you got to multiply the top and the bottom. So, like on this, if you do, like in the calculator, so let's look at this for a second. If I do 3/4, if I multiply that times 6, guys, all that's doing, that's treating it like 6 over 1. If I multiply it by 6 over 6, what do you think is going to happen? Remember, the calculator simplifies it for us, doesn't it? Did it change it at all? No, because the calculator is going to simplify it for you every time. These are all equivalent because what do they all really equal? 3/4. So the calculator can't help you with those equivalent ratios because it takes everything to the simplest form. All right? Number 29. What is 20% of 100? Now this one, guys, y'all should be able to figure this out in your head. 20% of 100 should be pretty obvious. But let's say we're having a little bit of like a brain malfunction. It's the test. We're overanalyzing things. It happens to a lot of y'all in here. Okay? What would be the mathematical way that I would actually solve this? What would I need to do to solve this type of problem? Brittany?
You would multiply. Well, first you have to change the 20% to a decimal and then multiply it by 100.
Okay, so we're going to change our 20% to a decimal by moving the decimal to the left to lose the percent. So that becomes 0.20. Of means multiplication, and we're multiplying by 100. So what do I get when I do 0.20 times 100? Gabby? We get 20. All right, because 20% of 100 is 20, which should make sense because what is percentage always comparing our number to? 100. If that's already 100, my answer is just 20. If you make a 20 if you get 20 questions out of 100 correct on a test, you made a 20%. Yes. All right, right here, 20 over 100 would not be the correct answer because it's not asking you for the ratio. 20/100 is smaller than 1. I'm not saying that 20% of 100 is a smaller number than 1, am I? It has to be just 20. 20% of 100 is 20 whole amounts. So think about this square down here. If I wanted to color in 20% of this square that has 100 dots, how many squares am I going to, 100 squares, how many squares am I going to color in? 20. Because, am I going to color in 20/100ths of a square? No, I'm just going to color in 20 squares. Does that make sense? Okay. All right, so, okay, we already did that one. We skipped over this bar diagram, though. How many spaces are in this bar? 10. And I wanted to color in 20% of it, correct? Now, some of y'all, obviously, we know 20 over 100 would simplify to 2/10. But another way we can do that, if I'm wanting to find 20%, and I would write this down just because I think this is good for us to know. If I wanted to find 20% of 10, what am I going to change 20% to? 0.20 times 10. What do I still get as my answer there? I still get 2. So we're still going to color in 2 rectangles. Okay, in my bar diagram. Again, what we were saying earlier, we know 20 over 100. That's this diagram. But if I divide that by 10, That gives me 2 over 10, which would be my bar diagram. Okay? Questions about 29? Andrew?
If it was 21, would you really do the bar diagram or no?
My bars would have to be separated differently.
Okay, so technically you couldn't really use the polar bracket because any number that doesn't end in 0.
No, because you could do like 65. You could do 35, just split it up into 20 boxes, because 25 will go and do 100 20 times. So then I could split it by 5s. Okay. Bella? You don't need the 0 at the end. Okay. All right, so what Bella's saying is when we do this 20%, when we make that a decimal, that 0 is unnecessary. I just wrote it in to keep continuity. All right? All right, guys, we need to pick it up because the bell's going to ring in shortly and we don't want to be interrupted. So let's look at number 30. Here's my ratio. We have 4 to 6. It says the sum of two numbers is 200. The two numbers ratio is 4 to 6. Again, what does the word sum mean? Adding. So I want my two numbers to add up to be 200, but they have to have a ratio of 4 to 6. So real quick, what do 4 and 6 add up to equal? 10. Do y'all agree with that? Yes. All right, so what I'm really doing is I'm splitting up my 200, and I'm splitting that up by 10. So what is 200 split up by 10? 20. All right, so guys, let us finish up this one really quick. So 20, we're going to multiply that by each number. 4 divided by 20 is 80. 6 divided times 20, I'm sorry. 6 times 20 is 120. So if I add 80 and 120, what do we get? 200. So my answers here are 80 and 120. Guys, we're going to keep working because, again, this video is going to be posted online. So we're going to keep going. We're going to finish checking these problems. Y'all have a test on Friday. If your first bell, you can pack up your things and go. Please return my calculator if you signed one out. But the rest of us are going to finish checking this because we still have like 5 more minutes until that next bell.
I didn't even get to learn this course.
You can do it in a second bell because you're third, so you're fine. Okay. So I get 80 and 120. My first bell people can go. All right, please remember, watch the rest of the video online. All right. Are there any questions on how we got 80 and 120? All right. Let's skip down and do 32 because we work it pretty much the same way. So while that's fresh on our mind, we can work it. Ben, would you mind closing that door so it's not so noisy? All right. If the ratio of purple to black flowers is 4 to 8. So first of all, I'm going to start out by writing purple flowers and black flowers. And what's my ratio? 4 and 8. Are y'all okay with where I got that from? Okay. There are a total of 180 flowers. What does total mean we're doing? We're adding them, correct? So let's add. What's 4 plus 8 give me? 12. All right. Now, how many flowers are we actually trying to get to? 108. So that's what I'm going to split up by 12. So 108 divided by 12 gives me 9. What am I going to do with that 9 now? That's what I'm going to multiply. So 4 times 9 is? 8 times 9 is? 72. 36 plus 72. Does that equal 108? Yes. Yeah, just a good way to double check. Amelia?
Is it okay if we did it with the box?
Yes, okay. So up here on the board is where we have that box option where we draw out our 4 boxes, and then we can draw out our 8 boxes, and then split up 108 into that. Yes. Okay? So how many of the flowers are purple? 36, because if I look under, here is my P for purple, that was 36. How many are black? 72. Okay. All right, let's go back up, converting these to decimals. Guys, this should be super fast. If you need to pause or rewind or rewatch at home, please do so. To lose the percent, we go to the left. So here I get 0.17. To lose the percent, again, we go left. Now remember, there is a gap here. What am I going to put in that gap? 0, so I get 0.03. To get the percent back, to put it right where it goes, we're going to go to the right. So here I get 20% because, again, there's that gap right there. All right, and then for 45, we're going to go to the right twice, and we get 45%. Remember, if we're talking about a percent, we have to have our percent sign. All right, the last one y'all were supposed to work last night was 33. If you didn't finish 34, 340 last night, please do that tonight. It wasn't required, but we were supposed to get to 33. All right? It's saying, what is her speed in words per minute? So what has to go on top? Words. So we're going to put 3,000 words. And what goes on the bottom? 20 minutes. Remember, if we're wanting to get 1, we're going to divide them both by 20. So we should get 150 words. And our whole goal here was to get what on the bottom? 1 minute. So now we can write out our sentence. Please make sure you put 150 words per minute. The words per minute is very important.